data model. So where you will source the data from different databases, and then you will create one data model where you will create an entity relationship diagram like ERD diagram. So and that data warehouse or data model will be consumed by some other team. There's a data scientist team or the blockchain team. So they are going to cover that. They are going to consume that data warehouse or data model. So in case of the data model, let me. So are you able to see my screen now, or you are not
No,
able to see?
no,
You are not able to see.
no, no, sir.
Okay. Uh,
It's all fundamentals of the database, correct? Yes,
yeah,
logical
yeah,
model.
yeah. Just a minute. So as I told, the data modeling. So as I told, in case of the data modeling. So do you have any knowledge on the data modeling part?
I know the
Hello.
basics. I know the basics. Logical model. What does?
Okay. So what happens? See, you need to create a data model if you are going to work in any kind of data engineering project. So there you'll be having different kinds of databases. You'll have the data on, let's say, on premises. You will have the data on, let's say, some SQL server, or data is there on S3. So what you need to do, you need to uh, source all these data to data lake, and then you need to use some data warehouse, and then finally you need to use some visualization. Okay, this is fine. But in case of data warehousing, so this will be your final layer. So where you need to implement a data warehouse, a data modeling, right? So in case of data model, see, data are coming from different kinds of sources. But in your data warehouse layer, you cannot have a, you cannot like you cannot include all the tables from on premises, all the tables from SQL, all the tables from S3. You don't need that, right? Let's say you are building a data model for marketing. Okay,
Okay.
so in that case you need to only import marketing data, right? So there you need to have a table. In case of data model, what you will have, let's say you are have customer table, you will have order table, you will have sales table, and then you need to create some kind of relationship between them. Okay, so this is known as data model. Okay, so this is known as data model. And so in the data model, as you can see, there are different layers of the data model. So you'll have, so data model is nothing but the process of building the data model. And why we are using it, as I mentioned, like we are going to build any kind of data warehouse or any kind of BI solution. So for that we are going to use the data modeling technique. And as you might know, like in the data modeling, will have first the conceptual data. So in case of the conceptual data, you will have only uh, so in case of let's say you will have a requirement, So uh, let's say requirement you have. Then from the requirement, you'll analyze something and you'll have a conceptual data model. You'll create a conceptual data model. Okay. So in case of conceptual data model, what you'll have, you will not have any fields. Let's say this is your customer data, customer table. One table you will have for order, one table you will have for sales. And okay. And you will just define like my customer table will be related to order table and order table will be linked with the sales table. So this will be your conceptual data model, and you will create this data model based on the requirement which you will get from the business or client. You will have the various level of discussions with the client and business, and then you will create this conceptual data model. After creating this conceptual data model, then you will go for the logical data model. So mainly conceptual data model, if you are working as a developer. So if you are working at mainly if you are working as an architect or some senior position, you are going to create this conceptual data model. And then next level will be your logical data model. So next one will be your logical data model. Okay. So where you will have same table, let's say customer, order and sales. But here you will have the fields. Let's say in customer table we have customer ID and some other customer information field. Similarly, in order table we have order ID, also the customer ID, where which you can link with this table. And in the sales table, let's say we'll have the product ID and some other product information, and also the order ID. So that you can link the order table and sales table. So you will have all the primary keys defined in the logical data model. Also, you will have uh, the data type of each field. Also, you will create some kind of relationship. So all these things you are going to do only in case of logical data model. In case of the conceptual data model, which you create on the basis of the requirement you will get from the client. So that case you'll just have the customer order and the sales table, and you'll assume that in our future data model we are going to have a link or relationship between the customer order and order sales. Got it?
Yes, yes, sir. Here no primary key is needed, right? Like in conceptual.
Yeah, in conceptual there will be no primary key, no fields and nothing. Okay. And the next one will be your physical data model. Okay. So physical data model will be your fundamental data model which will be used by the developer. Okay. On the basis of physical data model, they will create the data model on your DBMS system. Okay. So here what will happen? You will have all the primary key. So you will have everything, whatever is there in the logical data model. Along with that you will have also the data type, data field length. Data field length means the length of each column. So that you will have here. Also, you will have any kind of the column names. All the column names are clearly defined. Okay. So what I mean by that is, let's say you have a column name as customer ID. Okay. This is how you have defined in case of your logical data model. But in case of physical data model, you define the customer name with a proper column name, customer ID as a proper column name with a underscore here. So you'll have a particular proper column name and everything, all the primary key, everything will be there in the physical data model. And this data model, this physical data model, will be used by the developer, and they will work. They will use that to create all the tables and columns and the structure of the data model. on any kind of the DBMS system. So that's all about the data modeling. Okay, so let's go through the slides. So as I told, there are mainly three types of data model: conceptual, logical, and the physical. So in the logical data model, you will, on the basis of the conceptual data model or the data requirement, you are going to build logical data model, and that logical data model will work as a fundamental level in order to create your physical data model. So in case while creating the physical data model, as I told, you will have everything defined: the column name and the column name, everything will be defined properly. So again, going in detail, in case of the conceptual data model, it will have only what system contains. Okay, as I told, you will have customer, sales, and order table. You will not have any other details. So this is the first version of the data model. It cannot be used to build any kind of database or so, or anything like that. And the conceptual data model will be created once you get the business requirement from the business client. And next page is the logical data model. So here also you can see logical data model. If you are working as a business architect or any architect, so you are going to build this logical data model, because architects are the one who will create the architecture of the data warehouse, and that is the logical data model, where you have the design of the data model but not the physical implementation. Physical implementation we are going to do on the physical data model. uh, so this is the foundation layer for the physical data model, and here you will identify how the system will be implemented, but we have not yet implemented. So that's why we are calling it as a logical data model. And in case of the physical data model, you will have everything defined: the column type, length, if any column is be null or not. So that will be also defined here, and all the relationship will be defined clearly. So after physical data model is defined, the developer will work on it, and they will create the data model on the data warehouse. So these are the examples which I was talking about. In case of conceptual data model, there will be no primary key. Your data model will look like something like this. There will be, let's say, there are three tables: customer, order, and product. There will be relationship between the customer order table and in between order and product table. So this is how the conceptual data model looks like. In case of the logical data model, you'll have the primary key, foreign keys, all are defined. You'll have attributes, but you will not have the proper length and the proper name to the columns. Okay, it will independent of the system where you are going to implement your data model. At this time, you don't know how, on which DBMS system you are going to create your data model. DBMS means whether you are going to use it on Azure SQL or in Cloud SQL or any other databases, or in Cloud Spanner. So you don't know about that. So and again, in the next page, which is the physical data model, where you have everything. You'll have the primary key defined. You'll have the proper column names. Also, you'll define if any column will be null or not. So all those things will be defined here on the physical data model. Next is the ERD diagram. So if you are working as a senior data engineer or any kind of lead data engineer, you will be uh, given the work to design the ERD diagram. ERD means entity relationship diagram. So this is how. So where you need to design your data model, you need to design your logical data model. So it looks something like this, and there are different kinds of tools. Have you ever designed any kind of data model? Have you ever created anything like entity relationship diagram using any
Using
platform?
Erwin, yeah, you using Erwin have developed it.
Okay, using ERN. So there are other platforms like Lucid Chat and all. So which also you can use to create the ERD diagram. And when you are creating ERD diagram, you will have mainly three components, uh, like entity, attribute, and relationship. So entity are nothing but the tables. Like this, you'll create some tables, and attributes are nothing but the columns. So on those tables, you will have columns. Also, those columns you will need to define which columns are the primary key and which are the foreign key, and you need to also create the relationship between them. because this is how a logical data model looks like, and this will be used by the developer, actual developer who are going to create all these tables in any kind of DBMS system. So this will be used for the implementation. Okay, so on the basis of that, you need to create a clear EID diagram so that when you will give your EID diagram to any developer, he or she should be able to understand the complete relationship. What are the tables they are going to use? What are the constraints, like the foreign key, primary key? What are the constraints they need to create on those tables? So everything should be clearly visible and clearly defined on your EID diagram. So next is you might be aware about, you might be knowing some of the keys which we using in our data warehouse, but I don't think you know all of these keys. So let's say yeah, these are the different types of keys which as a data engineer we should know, and it will be asked on your in any interview if you are going to attend, or it you need to know because tomorrow you might need to use this on in your project. So we all know primary key. So primary key, it will be there will be only one primary key, in like unique primary key, and it will be only one column on a table, and it will be unique for each row. Also, the primary key cannot be null and it should be unique. But when it comes to candidate key, so candidate key is also a type of primary key, as you can see. So this is also a type of primary key which is unique, but it's not. It cannot be null. But the difference between candidate key and the primary key is you will have only one primary key on the table. Let's say customer ID is a primary key, so you will have only one column defined as a primary key on a table. But when it comes to candidate key, you can have multiple columns like candidate customer ID and the ID card number. Both are defined as a candidate key, so you can have more than one candidate key on a table. And then comes to composite key. As the name suggests, the composite key is the combination of the different fields. Let's say you have an ID card with a date, or with some let's say some roll number. You combine all the three or two fields to create a composite key. So sometimes we also create composite key as a primary key. And then next comes to natural key. So natural key is like, let's say if you have a database, let's say you have a database for student, and in that case whenever a new student will take admission in your institute or in your organization, you will assign him a ID card number, and that will be unique, and that comes naturally to your database. Okay, so that can be used as a primary key. So since it comes naturally to your database, whenever a student comes to your uh, organization, you will create a ID card, and that ID card or ID number will be unique for each student. We call it a natural key. And then next is surrogate key. So surrogate key it does not have any business meaning like customer key or customer ID or product ID, but it's kind of a you can say it's a unique key which we normally generate while running while loading the tables into the data warehouse. Let's say in any table there are no primary keys, but you want to create a primary key for each of the record that is being inserted to a particular table. So but you don't want to have any business meaning to that column. You just want to create a primary key. You just want to create a key for each record you are going to insert into a table. So in that case, you can create a surrogate key. So there are different methods. When you are designing a pipeline, you can use any like Spicebar script or any pipeline parameter you can pass to create a surrogate key. And next is foreign key. As we know, the foreign key is like, in order to build any kind of relationship between two tables, so one we can create foreign key, like the foreign key of one table will be a primary key in another table, so that we can create a relationship between the two tables. it will join two entities or two tables. So these are the different keys. Any doubts you have till now?
No, sir.
Okay. Next comes to the normalization. So normalization, as you know, uh, so uh, so whenever you are creating multiple tables out of one table, let's say there is one table which is having all the data. Uh, let's say there is one table, sales table. Okay, or let's say it is a customer table. Okay, but this table has also the sales data, also the order data, also the customer data. So when you are going to normalize a table, so what you do instead of, since this table is having all the data, so it will have sales id, it will have customer id, it will have order id, so everything will be there on a same table. So there will be a lot of repeating groups, you can say, right? There will be a lot of repeating groups. So so that in order to for data redundancy, so that we can eliminate if there is any duplicacy on the table, we go for this normalization. So what will happen, we'll create three table instead of one table. Let's say one will have customer data, one will be having sales data, one will be having order data, and then we'll create a relationship between these table. So this is called normalization. And this is very important question, you'll get in the interview. They'll ask you about the normalization. What are the types of normalization you know? So there are mainly in industry we are using three types of normalization. Okay. So first one is fast normalization, then second normalization, and third normalization. Also, they will ask you how you are going to do the first normalization, how you are going to do the second normalization, how you are going to do the third normalization. This is a very important question which you are going to face if you are going to attend any kind of data engineering interview. Okay, so let's understand that. So in case of faster normalization, as I have mentioned, it will have a primary key. You'll have a single, should only hold single values attribute, and it must be atomic. Okay, and then there will be no repeating groups. So let's understand what is how we can do the fast normalization. So there are 3 points. One is primary key. It should be atomic. There will be no repeating group, and it should have a single values. Let's say we have a table like this, okay, where we have name, address, and the phone number. So first one is we need to have add a primary key, then only we can call it as it's first normalized. So we'll add a primary key. And next one is it should hold only single values at attribute means we know columns, right? So here we can see on the names, we can divide the names into first name and the last name. So that is what we have done, and it should be atomic and it should be single values. So once it is divided, you cannot divide for the first name column or the last name column. You cannot divide further. Okay, so then we can call it this table is normalized, and this is on the fast normalization for, because we have added the unique primary keys. Also we have divided the columns into single value attribute. Then I can say that my tables is fast normalized. Also another point is that there will be no repeating groups. So repeating groups means you can say these groups are not repeating, right? Let's say for 101, whatever the group is there, like first name, last name, address, and phone number, this row is not going, not it's not repeating in any uh, on the next rows, right? So we can say that we don't have any repeating groups on this table, and my table is first normalized. Okay. Next come to second normalization. So in case of second normalization, my table should be on the first normalized form, and after that we are going to perform these steps. We are going to eliminate any non-key columns that should be dependent on table's primary key, and we will eliminate any redundant data, and it should not contain any partial dependency. Okay, let's see how we can do that. So here I have a table, and this table is fast normalized because we have the primary key. Let me have some water. Also, you can see the price and quantity. These two columns, two columns depend on order ID and the product. Okay, but the order date and shipping details. These two columns, I can say these two columns are related to the order ID, but order date and shipping details. Uh, these two columns are not related to any kind of product or product ID, right? So I can say this is partial dependency because my composite key, my primary key, composite primary key is order ID and primary product ID. For second normalization, my condition is it should not contain any partial dependency on the data. Partial dependency data means whatever the non-key columns are there, it should be depend on the table's primary key. It should not depend partially on the table's primary key. If that is a partial dependency, we need to eliminate that partial dependency. So that is what we are doing on the second normalization part. So here we can see this order data and shipping details data. You can see each row, you can observe each row, and these rows does not have any relevancy with the product ID. They are related to the order ID, that I agree, but they are not related in any manner to the product ID. Okay, so we can eliminate this and we can create another table out of it. We can create another table with order date, shipping date, and order ID. Then we can relate these two tables. So that is what we will do in the second normalized form. Next one is the third normalized form. In the third normalized form, what we are going to do, your table should be in second normalized form, and then you should eliminate the columns which are not dependent on the primary key, and you should not have any transitive dependency on the on your table. So let's understand that. Here, my this table is in second normalized form. Under transitive dependency means if let's say these three columns, just focus on these three columns: supplier ID, supplier name, and the supplier address. Okay. If you see the supplier ID, the supplier name, and the supplier address, they these two columns depend on supplier ID. That is fine. But these two columns, supplier name and supplier address, and this is my primary key on this column, the product ID. The supplier name and the supplier address, they are not related, or they don't depend on the product ID, right? So what we can do, so my rule says for third normalization, we need to remove the transitive dependency. So this is called transitive dependency because this supplier name and the address, it depends on the supplier ID on in other key, but it does not depend on the primary key. This is the primary key on the table. So in that case, what we are going to do, we are going to eliminate that transitive dependency. So after eliminating, we'll create two tables. One is for product, which will have product name, supplier ID, and the unit price. For supplier information, we'll create another table. So that will be having supplier ID, name, and address. This supplier ID will be act as a common key between the product and the supplier table. Okay. So is it clear till now, or the normalization part, or in doubt?
Yeah, clear. It's clear. I already know this concept. So
Sorry.
it's clear here. I already know this concept.
Okay. So you already knew all these concepts.
Yes, yes.
Okay. And next one is your dimensional modeling. So in case of dimensional modeling, what will happen? So if you know the dimensional modeling, we mainly do for to in order to create any kind of data warehouse or business intelligence application. So in case of dimensional modeling, we have two concepts like the fact and dimension table. So you will create a fact table, and also when you are doing the dimensional modeling, there are two types of methodology which you will follow. Either you will go for snowflake schema or you will create the star schema. So let's first understand the dimension and the fact table. So in case of the dimension table, you will have the descriptive information about the facts, and whenever you are creating any dimensional model, you need to first create the dimension tables. So as you can see here, we have the order table as the fact table, and all this table like employee, customer, product, and the date. So these are the dimension table. Okay, and whenever you are creating this database or creating this data model, so first you need to create the dimensions table. And in case of the fact table, you will have the primary key of all these dimensions table. You'll have the employee ID, you'll have customer ID, date ID, and the product ID. All these IDs will be present on the fact table. Along with that, you will also have the measurement of business measurements on the fact table as well. Okay, so that is called as dimensional modeling. And next, let's understand. So there is one more important concept which we should know, and that is known as slowly changing dimensions. The dimension which change over time. Okay, so this is also one of the important interview question you will get in. You'll be asked. So they'll ask you how many types of SCD you know. What are the SCD you have used in your project? So you also know all these SCD concepts.
Yes, yes. Currently, we are using type 2.
Sorry.
Yes, yes.
Okay,
Currently, we are using
fine.
type 2.
Okay. So in case of SCD 0, so there will be no change in the data warehouse, because the changes which we are making on the table, so we assume that that is not relevant. So let's say here, as you can see in these two tables, uh, the fax number has changed. So this is the table which already loaded into the data warehouse, and then when we change the fax number, so we assume that the fax number is not relevant with the for the analysis which we are doing. So that's why we didn't update the fax number, and that is the scenario where we are going to use SCD 0. Okay, and then let's understand SCD 1. So in case of SCD 1, you can see, I think I have not updated here anything. Okay, fine. So in case of SCD1, what will happen? We'll override the old value. Let's say the fact number is there, or let's say the salary is there. Okay. So in the data warehouse, whatever the data is there in the data warehouse, the salary is mentioned as 10,000, but the updated salary is 20,000 or 30,000. And we think that the salary is a very important information. We should update that in the data warehouse. So that will overwrite on this record, that is known as SCD1. Okay, as it says, it will only reflect the recent update. It will not have any historical changes. So that is known as SCD1. In case of SCD2, so you will have the history as well as the current information. So as you can see here, so my data warehouse, let's say uh, this record, the office is California from the effective date 10 Jan 15. Before 10 Jan 15, the office was Bangalore. Okay, and this is my old record. The first record is my old record. So I'll add a to date and the current flag. Current flag will show whether the record is a valid or not. So we'll update that current flag also with the date, and this is my current record. So that will also update on the data warehouse. So since going to uh, we are going to have both the history as well as the current data. So that is what we are doing in the SCD2. And next is SCD4. So in case of SCD4, what we are doing, we are going to track any changes separate to the dimension table, and the main dimension table will keep with the current data. So that this is the main dimension table. So there will be two tables in case of SCD4. One will be for historical data, another one will be having only the current data. So this, as you can see here, the office has been updated as the house term. So this is my current table. This will have only the current data. But here, this is the historical table, which will be having all the past offices and also the current offices. So everything will be updated on the historical table. And next one is your star schema, which I was talking about a bit, like I was talking about sometime before. So in case of star schema, what you'll have the fact table in the center, and you'll have all the dimension tables surrounding that fact table. And as I said, the dimension table will have all the dimensions information, and you need to create the dimension table first. Under the fact table, we'll have all the measures information measured, and along with the keys, we have the primary keys of the dimension table. So this is your star schema, how a star schema looks like. And the next one is your snowflake schema. So in case of snowflake schema, what we'll have, you'll or normalize. As I said, normalization means we'll further subdivide the table. We divide the table into different subtables. That is known as normalization. So in case of star schema, all the dimension table whatever are there, again you will further divide those dimension table, or you will normalize those dimensions table. So that is what we do on the star schema. Sorry, on the snowflake schema. So any doubts till now?
No, no, sir.
Okay. Also, let's understand about some of the concept of the cloud computing. Okay. So in cloud, we have generally we use three types of services, whether it is AWS, Azure, or GCP. You will see these three types of services are present in all the cloud vendors, and those are infrastructure as a service, platform as a service, and the software as a service. Along with these three types of services, Google also provide two more service models. Okay, along with these three types of services. So those are, you can see on the screen, those are functions as a service and the container as a service. Container means if you have any knowledge about the Kubernetes, then we have something called GKE, Google Cloud Kubernetes Engine, where you can create container. If you are using Kubernetes, also you can use on your on premises on your local system. So that also you can integrate with the Google Cloud. So that is what container as a service means. And the functions as a service means, if you have worked in, do you have any experience in other cloud platform?
Azure, I'm working as Azure engineer, data engineer.
Okay.
Since from
So have you used Azure function?
logic apps, right?
Yeah.
Yes.
Okay.
Send
In
the
Google Cloud, we
notifications.
have. Mhm.
Send notifications in the form of mail.
Yeah, yeah, yeah. So functions as a service, what it does in Google Cloud, we have something called cloud function, Google Cloud function. So it will get triggered based on an event. Okay, let's say you upload a file in storage, then the cloud function will get triggered, and that is known as functions as a services. So let's understand what is service, software as a services. As you know, the software as a services means users will not know any softwares or tools which are being used in the services. Okay,
Gmail.
they'll just use the services like the Gmail and the Google Drive. We don't know which tools and which software are being used on the background of Gmail and Google Drive. We are just using it, and you will pay as you use. So that is how the software as a service works. In case of platform as a services, you provided a platform where you can create your software, you can deploy your software. So, but you will not have any idea about the infrastructure. Okay, you will not have any control over the infrastructure. You will just focus on the business side of the application, how you are going to scale your application. Let's say the best example will be GoDaddy or Wix.com, if you know. So there you can create your web page, but you don't know how you are going to host your that web page, what is happening in the background. But you can just create a web page on the GoDaddy and Wix. So that is all those web hosting platforms are the best example of the platform as a services. And then next one is as we were discussing, the container as a services. In case of the container as a services, you will create a container. So if you have worked on Kubernetes, you might be aware about the pods and the container which we create on the Kubernetes. Inside the pod, you need to create application file, any dependency. Let's say if you are if you are deploying any kind of machine learning model, there will be lots of dependency. If you are creating any model, all the Python library and all, and the configuration settings, everything you need to include inside that container or the pod, and then you will deploy that pod on the Kubernetes services. Okay, so Google also provides you a virtual container, and that service of the Google Cloud is known as Google Kubernetes Engine. Also, we are going to do hands-on on Google Kubernetes Engine as well. In case of functions as a services, as we know, like it will be triggered once an event is occurred. So we have cloud functions, we have in Azure, we have Azure function, in AWS we have AWS Lambda. So these are the examples of the functions as a services. In case of infrastructure as a services, so Google Cloud service, cloud provider will give you server as a rent. You can configure all the infrastructure and the configuration setting. So you can let's say you are going to use cloud Google Cloud Compute Engine or Google Cloud VMs or Google Cloud Google. If you are going to create any instance in the Compute Engine, so that will be known as your infrastructure as a services. Any doubts so far?
Good, yeah, I'm good, yeah.
Sorry.
No doubts. No doubts. No doubts.
Okay. Okay. And also the cloud deployment model, if I talk about, so we have different kinds of cloud deployment model, like we have public cloud, community cloud, private cloud, and the hybrid cloud. In case of public cloud, it will be open for the public uses, like you will pay for whatever the services you are going to use. For example, AWS, GCP, Azure, these are all public clouds. In case of private cloud, it will be used only by a private entity, let's say HP or IBM. So they will have all the private cloud. You cannot access their cloud environment. Also, in case of community cloud, if it is open for all for a particular community, like IBM, they have some community cloud for all the US federal states. So that's known as community cloud. Also, hybrid cloud, if it is has both public and private, then it's known as a hybrid cloud. Okay. So what are the private provider we have? So these are the major private provider we know, like Google Cloud, DigitalOcean, AWS, and Azure. These are the major cloud provider. Okay. And let's also from the next class we'll start with the GCP services. We'll start with Google Cloud fundamentals. Like if you are working on Azure, you also might be knowing about all these regions and the zones, and what are the regions and zones, like why you need to create multiple regions, how you can achieve a low latency or disaster recovery, how you can do that. So all these things I think you might be aware about, but let's discuss this today's class only. So currently, if you see, Google services are available in I think 37 region or 37 zones. We'll have a Let's see that on their official website. So this is the link for the official website. I have also given you this link on this slide. So if you go to this slide, you can see currently the Google Cloud services are available on 32 regions, 97 zones, and these are the countries and the territories where the Google Cloud services are available. So let's say why we are creating. Let's say if you are creating any machine learning application and your machine learning application is being used by your client. Uh, so if your client, most of the client you are getting from US, and if you have deployed a machine learning application on the data center which is in Asia, in that case you will not achieve the low latency, right? So you need to create another services. Sorry, you need to deploy your application on US region. Okay, so that's the importance of the regions and your zones. Also, there is something called you all know, like high availability. Let's say one region, if the service is down, let's say in Asia South 1, in that case client can consume the application from the other region. Okay, that's why for disaster recovery we use all these regions and zones concept. Okay, and if you understand in detail, so in a particular region we'll have multiple zones. Let's say in Asia region or South Asia region we'll have, let's see it on here. So inside each region, inside Asia specific region, we have the zones: Mumbai, Delhi, Singapore, and all the zones, Hong Kong, Taiwan. Similarly, in US region, we have all the zones: West 1, West 2, West 3. So inside each region, you will see multiple zones, and then multiple regions are collectively known as so inside multiple region you will see collection of geographical region, and the global means you can you can see you can relate this to the planet, you can say. So inside the planet we have multiple regions, and inside multiple regions we have different regions like Asia, America, Europe, and inside regions we'll have the zones. Okay, so that's all for